for the other laws of nature, such as electromagnetism, or the velocity of light changes given the motion of its source. But then if you say the velocity of light changes given the motion of its source, which would be a consequence of the relativity of motion, what we spoke of earlier of the addition of velocity, or you could say the subtraction of velocity, that being a simple consequence of the relativity of motion. If you say the velocity of light changes because of the relativity of motion, you're saying that the law of the constancy of light is not true if it's put into motion. So it kind of breaks down. Because remember, Einstein's question was, is there a relativity for all of nature's laws? Not simply for the laws of mechanics, but will all of nature's laws be maintained given motion in a uniform manner, or if you're stationary, if you're viewing them from a stationary reference frame? So this precise experiment of the Michelson-Morley should have settled that. But for most physicists at that time, 1880s, and this experiment was performed for decades, over and over again, more and more precise instruments at different heights, at different depths, different locations, different times of the year, different angles. It still baffled scientists that there was no interference between the two rays of light. It's what was called the null result. There was no difference, the arrival times, of either ray of light. So for Einstein, this wasn't necessarily surprising. What was surprising was, what was he taking for granted that made him expect the reverse? What in this experiment is being overlooked that makes us surprised by its results? So he rolled it over in his mind. Said it's a pretty clear setup. I understand what the task is. I understand what the components are. And I understand that the rays of light are received in the interferometer simultaneously. But do I really understand that? Do I understand what is meant by two events occurring simultaneously? And it seems clear enough if you think about two balls hitting the same target at the same time, two events occurring in the same place. That seems sort of clear of what simultaneous means in that situation. But what do we mean by something being simultaneous in different locations? What do we mean by something occurring in this room and another event occurring somewhere else in the world simultaneously? What do we mean by that? So Einstein in his book asks his readers to consider this carefully. How would you set up an experiment to test a conception that you're so comfortable with? Because for a physicist, no conception is acceptable unless you have a method to experiment with it, to test it, to prove it. You can't just simply say, oh, it's obvious, can't you see? You have to be able to define it in a way that gives you a method to test it. So he sets up a thought experiment where you have an observer standing in a grassy field as a maglev zooms by. And at the moment that the observer is facing the middle of the train, two bolts of lightning strike either end of the train. And to the observer, he says it happens simultaneously. So here's our observer in the field. So lightning's pretty fast. Yes, our friend Motoki risked his life for science to test his hypothesis of simultaneity. So when we asked Motoki to be more clear about what he saw, can you, in a less confused manner, tell us what you observed? Sure, you tell us that the bolts of lightning are simultaneous, but how could you prove that? How do you know that? And he says, well, okay, fine, I can prove that. I know they occurred simultaneously because when they occurred, I was in the middle of the train. My direction lined up with the middle of the train, and either bolt struck the ends of the train, and since my distance to each bolt of lightning was equal, and they travel at the same speed, both flashes of light reached me at the same time, meaning that when they traveled the same distance at the same velocity, they reached me at the same time. They had to occur at the same time. Okay, that's pretty precise. That we can test to experiment. But what about for an observer who's sitting on the middle of in the middle of the train, sitting in the train, in the middle car, and the same event happens? Well, what are they going to see? The bolts of lightning are going to strike either end of the train. Each bolt of lightning has an equal distance to travel to reach the passenger inside the train. But what are they going to see? Here's our anonymous volunteer, waiting patiently for their observation. So here's the front view of the train going forward, and the rear view of the train, where each bolt of lightning is struck. So what does the passenger inside this train see? Would they say that the two bolts of lightning struck simultaneously? For them, the lightning bolt that they are approaching, the lightning bolt in the front end of the train occurs first. And the second bolt at the end of the train reaches them second. And if we were to ask them to explain their observation, they would give us a similar explanation of Motoki. I was sitting dead center in the train. The first the first flash of light and the second flash of light have an equal distance to travel to reach me. And since the velocity of light is equal, or since both flashes of light are traveling at the same velocity, I observed one flash first and a second flash, and the second flash after. Then, therefore, since they traveled the same distance at the same speed, the first bolt struck first, and the second bolt struck afterwards, according to my observations. So who are we going to trust in these two scenarios? It's the same event. Same train, same two bolts of lightning. One observer from the outside who's standing still says the event occurred simultaneously, the two events. Thank you, Motoki. The observer on the train argues otherwise. The conclusion that Einstein came to was that the velocity of light in each reference frame is constant. But instead, what is changing is the time that we're using to observe these events. Since we can't say that simultaneous events are something which is absolute, since the concept of simultaneity is not a true concept, no matter the observer's motion, since the idea of two events occurring at the same time depends on your observing position. It's not something absolute. It's not something we can use as a measure in any situation. The idea of simultaneity is something crucial to time. The way we measure the passage of time is by coordinating, for example, the ticking of hands on a clock. That each second is simultaneous with the click of a